Happy Friday, everyone. If you can hear me, send a little nice note in the live chat. James, are you there?
I am here.
Thank you, James. James, thank you so much for joining. Really appreciate it. We'll give everyone a little bit of time to say hello. Hello, world. Oh, that's my favorite application. That's absolutely the best. So this is GCP Online Meetup number 12. It's, wow, 12 already. So my name is Jonathan Cham. I'm a customer engineer at Google, helping customers build great applications on Google Cloud Platform. If this is your first online meetup, welcome. We're super happy to have you. And these online meetups are just a way to have casual, informal conversations with a sprinkle of useful information, of course. So feel free to interact with us in the chat. When we first started, we were afraid that we're going to get too many people chatting, but no one wants to chat. It's weird. I mean, it's anyway. So, I got a special guest all the way from Austin, one of my favorite people. And, it's really funny. I think it was just a typical morning. And just like anybody else, when they wake up in the morning, first thing they do is check Hacker News and start reading an article. And boom, I said, hey, I know this guy, Mr. James Thorne. And James, can you tell me a little bit about that article you wrote?
Yeah, for sure. I was excited to see it actually made it to the front page. Usually that doesn't happen. I had submitted stuff before just on a whim, and they never really get anywhere. But I have my own personal blog that I've been doing for almost 5 years, and I like to move it around to different architectures just to learn, just to play, to understand how things work. And I recently moved it onto App Engine, tied together with a small Go application. And I wrote up that process, put it up on the blog, and then decided, why not? I'm going to post this link on Hacker News as well, see maybe if it gets anywhere. And within about 10 minutes, it was on the front page with, I think, like 20 points or something. And so I think throughout the day, it was up on the front page for a total of like 12 to 15 hours. So I had my 15 hours of fame, and then it faded into the past on the second, third, fourth, and now it's probably not even on a page anymore. But it was cool to have that, cool to see the traffic come in and just watch that experience happen. So
yeah, no, that was cool. You're like a reality star, like internet reality star. But yeah, I mean, obviously, do you want to give a plug to your website? I know you do a lot of like interesting technical projects on there.
yeah, sure. It's just a place I put a lot of my technical documentation that I've compiled over the years. Some of it's relevant to some people, some of it is not. And you can find it at thornlabs.net.
Thornlabs.net. It's my homepage every time I boot up my Chrome browser. Anyway, so I know we're here to talk about Kubernetes, migrating to Kubernetes. But before we do that, do you mind just doing introduction of yourself? What do you do, and kind of how you got into using Kubernetes?
Yeah, for sure. James Thorne, as Jonathan said, also a customer engineer. I've been at Google, I think 9 months by now. It's been a long 9 months, but a good 9 months. And for those of you that don't know, the term customer engineering was actually new to me. It's just another name for a sales engineer or a solution engineer. And our main focus is to work with customers on knocking down technical roadblocks, making sure they don't have anything in their way to actually get started on the GCP platform, and to make sure they have a good experience, because both parties want that to happen.
Yeah, no, that's great. Yeah, and James obviously knows a lot about, I mean, your previous work was at Rackspace, so you did a lot of work with just infrastructure and understanding the challenges. And obviously, cloud is kind of this next big thing. And our role is just to make customers successful on the platform.
Yep, for sure.
Great. So yeah, let's get started. And obviously the chat is open and we're ready to get going. So yeah, let's talk about how do we move an app to Kubernetes. I mean, it's not easy, not as easy as apple pie, but I would argue apple pie is actually really difficult to make.
A good apple pie, yeah.
Yeah, a good one, yeah. Not the $2, not the $1 for 2 apple pies at McDonald's.
Yeah, for sure. So this is something I put together before I joined Google, actually. So I got hired, and I started playing around with Google Container Engine, and I needed something real to play with. I didn't want to use just a basic Hello World app. I wanted a 3-tier web app to be deployed on top of Kubernetes, and GKE was the easiest way to get started. And of course, I had to start learning the product set. So this is pretty much what I'm going to present to you today, is what I went through in that process of getting this up and running. It's definitely meant as a getting started way to get started with GKE. So that's kind of my goal. And the first thing I want to show is the actual app. So this is a Python Flask web app called Snappass. It was made by a handful of developers over at Pinterest, and its purpose is essentially Snapchat for passwords. So they had a use case within Pinterest where they needed to securely share passwords with coworkers or whomever. But how do you do that? That's not a simple thing these days unless you have like a shared password manager or something like that. So I was looking for something very, very simple that just leveraged a web browser to get this done. So I'll show you what this app actually does. So let's say, Jonathan, I want to share a password with you. Like maybe I'm in charge of your G Suite account for some reason, and I just made you a user and it gives you your temporary password, and I want to share that with you. I don't want to send that over email. Granted, sending emails from a Gmail account to a Gmail account are encrypted, but still that password sits as in plain text in your email box. Bad idea.
And
don't want to send
not
over
best
a chat.
Practices. Yeah, not best practices.
Yeah, and I don't want to send that over a chat client. I don't really want to sneaker net it over to you. Perhaps you don't sit next to me or something like that. So I just wanted a simple, secure way to send you that password. So I can open up the web app. This is a running implementation of Snappass on App Engine. So this is completely separate from what we're going to build today, but it's another example of taking a web app and deploying it to a different type of infrastructure service. In this case, it's App Engine, which is a platform as a service running this. So just to show you real quick, there's your super secret password.
And is this containerized right now, or is it just an app that you deployed on App Engine?
So in this case, so I took the Python application, which could live in a directory on your workstation with App Engine. I had to change some of the code to talk to Memcache instead of Redis, because by default, Snappass talks to Redis, which is what we're going to be deploying on Kubernetes. But in the case of migrating it to App Engine, there is no Redis there. There's only shared Memcache.
Yeah.
So I had to change. It was actually only like 10 lines of code I had to change to make that happen. And once I did that, I then used the gcloud command to package up that Python directory with 1 or 2 additional configuration files that are needed for deploying to App Engine, and then it pushes it up in the App Engine standard, and App Engine is containerizing the app for me, and at that point, it's up and running. It puts the web front end there, it does the load balancing, it does the auto scaling, so it's nice to not have to worry about it. Now, this app does not get much traffic at all by any means, but it's there, and it's a good example just to have up and running. So
good.
Yeah, so let's say I want to send you this password. I put in the password, give it a TTL, so let's just say a day. And what that is there for, if I send you this password, by generating the secure URL, you'll notice this is a secure encrypted page. I can now copy that URL to my clipboard, and I can send this to you via some unencrypted or unsecured medium, whether that's email, chat, or whatever. And when you get it, you're going to open it up in your browser, and there's your password. Now, let's say someone grabs that URL. Somehow they were able, I don't know, they hacked your email or captured your packets in transit or something like that, and they were able to grab that email because it was transmitted in plain text. They saw that link. If they then, on their own, go and try to access that link, it 404s, because the moment you access that link, it shows you the password, it deletes the actual password from the Redis backend. And if the link is never accessed, then it'll eventually expire based on the TTL that you set. In this case, it was a day. So that's the app. That's what we're going to be deploying today.
Cool.
So I'm going to go back to my slides here real quick. So I showed that. You can go to the GitHub repository there. You can also just do a Google search for Snappass and you'll find it. But definitely go dig into the code. There's a decent amount of activity on that repository. I've contributed some stuff, and it's a great way to learn. That's my first actual repository on GitHub that I've contributed to. And it's a great way to learn how to interact with a community that you don't ever see on a daily basis or something like that. So yeah, definitely encourage that. So let's dive into taking this app and putting it on top of Kubernetes. So what's the simplest way this could be done? So taking Kubernetes out of the picture, we could just deploy this entire stack in a single VM. We could spin up a VM somewhere and download that Python app, download Redis, install that, and then put Nginx in front of it. If you didn't have Nginx, Python is going to sit and listen unencrypted on port 5000 by default, and you don't want to broadcast that onto the internet, of course. So you need to put some sort of reverse proxy in front of it. You could use Apache, you could use Nginx. I like Nginx. So I'm going to use that. And then SSL is also part of that as well, to make sure it's a secure communication. So this works, but it doesn't really scale. Like maybe for some reason you have a high amount of traffic come in and people using this service, one VM is probably not going to handle this. So you may want to start scaling this out. And perhaps you're using something like Puppet, Chef, Ansible, or Salt to deploy all these different components to a single VM. Well, that's great, and that gives you a repeatable process. But if you deploy to a new VM, it's going to be a totally independent set of things, and it's difficult to scale either of those things. So maybe you're thinking, oh, just clone the VM and stick a load balancer in front of it, which you could do. But the problem is the Redis piece. The Nginx piece and the Python pieces are fine because they're stateless pieces. So those can scale out as far as you want. But the problem is when someone comes in and talks to that load balancer and then hits one of the virtual machines, they're going to talk to Nginx. Nginx is going to reverse proxy back to Python. And that Python app is going to talk to the local Redis instance and store some sort of state there temporarily. Now, if someone then takes that URL that you saw me copy and paste it into their browser, and let's say they hit that second VM, goes through the stack again to Redis on the other side, that Redis on the other side isn't going to know about that piece of state that was stored in the other Redis because they're not clustered together. They're completely independent. So they're going to get a 404. And then the complete opposite could happen if someone tries to access it again. So that's not a good state to be in. So from an architectural standpoint, you want to break out Redis from this and decouple it from those two VMs. So now the two VMs are just Nginx and Python. Those are both stateless components. And then you have a separate VM, a single VM, running Redis where your state will live. Now, you could definitely cluster Redis, so you could scale that piece as well, but that's a bit out of scope for this particular use case and this explanation. So this is what we're going to build on Kubernetes, and what that looks like is this. So we still have our VMs because when you spin up, and in particular, we're going to spin this up on Google Container Engine, so we still have our blue VMs in the background there, and all the Kubernetes components are running there. And then on top of that, we're going to be putting these different pieces, Nginx, Python, and Redis, into their own respective pods. And you'll notice that Nginx and Python can be scaled out across the VMs, but Redis is going to sit on its own single pod with its own single container and not be scaled out for the reasons I mentioned earlier about replicating state. If we were to cluster this, we could then replicate this out. But clustering Redis is not a straightforward process. Kelsey Hightower, who is, in my opinion, a celebrity in the Kubernetes realm, has some good blog posts and videos he's done. I think it was at RedisCon or something like that, talking about clustering Redis. So definitely do a Google search for that, about running that on top of Kubernetes. So this is what we're going to build today.
That's awesome. Hey, so real quick, I mean, GKE is relatively new. Can you talk a little bit about the difference between Google Container Engine and Kubernetes?
Yeah, for sure. So underneath GKE, it is Kubernetes. It is raw Kubernetes, and of course, architected the way Google deploys it so we can manage it for you. It's kind of a hybrid managed service. I wouldn't call it yet a fully managed service from my point of view, but we're definitely moving towards that point. The biggest thing with using Google Container Engine compared to just doing Kubernetes on your own is that one-click deploy. I've done this demo for customers, and they made a comment that they were amazed how quickly the Kubernetes or the GKE cluster was created. I have a friend who works at another company who is deploying Kubernetes on his own internally for his company, and it's taken several weeks, potentially months, just because that process is not yet clearly defined really anywhere. And from talking with other companies who are trying to do the same thing, they're always getting different documentation or different ways of doing things and all that. So I think the Kubernetes community is working on building tools to make that process more mainstream and streamlined and all that.
Yeah, I think so. I agree with you that it's not fully managed because obviously when you do that one-click deploy, we basically configure and configure all the Kubernetes, the entire cluster to talk to each other. You know, we take care of patching, updates, security, all things like that. But technically, you still have access to the VM. You can go in and start changing things. So that's where it becomes a little bit not fully managed. Fully managed would imply you don't even see the VMs at all or any of the infrastructure. But yeah, some people want that flexibility, right? You know, to kind of go in and maybe make some modifications. Not typically it's best practice, but some customers want that.
For sure.
Yeah. And then so the next question, so you kind of described the difference between GKE and Kubernetes. I mean, Kubernetes requires you to containerize these VMs, right? Or these applications that you put together, like the Python and the Nginx. You know, are you going to talk about why containers?
I mean, that kind of turns into almost somewhat of a religious conversation to some extent. But I mean, the biggest thing is if you have a stateless application, that you need to scale out somehow. I mean, that starts to get you down the road of, yes, this is something that should be containerized, especially if you can package up into like a small amount of space, if you will. Like, you don't want to have 2 GB container files by any means. And actually, during the demo, the Python app, because of the way it's built, or because of the way the container built, does take 30 seconds to potentially a minute to scale out or build in some cases because of its size, compared to the Nginx container that I have, which is maybe 10 megabytes. And it's almost instantaneous to scale that out or pull it down from the container registry repository. So if you have applications that you can build in a small amount of space, you can wrap a container around that and then begin to deploy that out across your Kubernetes infrastructure if you need to scale that particular application out. And then it gets more interesting when you're talking about stateful services like databases or some sort of stateful app or something like that.
Okay, no, sounds good. All right, let's take a look at this demo.
All right, so let's go ahead and build this. I'm going to switch over to my Cloud Shell here. So I have a project in Google Cloud Platform called Snappass-that number. For the sake of time, I've already created a Google Container Engine cluster. That is this command right here. It takes a few minutes to spin up, so I did it earlier. So it's ready to go. There is nothing running on it. So it's brand new, fresh, ready to go. So the first thing we want to do is build our containers. Within Google Container Platform, or within Google Cloud Platform rather, there is the concept of a container registry that will hold all of your containers. There's nothing in it right now. And this is the registry I'm going to pull from to store my containers in when I deploy them to the GKE cluster. So let's build those first.
It's basically like a Docker registry, but
yeah, it's just like Docker Hub. It's specific to your Google Cloud Platform project. It's private to that unless you make it public. That's entirely up to you.
Yeah.
So yeah. So the first one we're going to build is Nginx. So I have a directory here called Snappass frontend. And then in this directory is a whole bunch of configuration files for Nginx. There's the Docker file, as well as some documentation as well and some SSL certs. So using these commands, I could build this container on my local workstation if I wanted to, and then push it up to the registry. But as of Google Next, we released our own container builder. So I don't have to do this on my local workstation anymore. I can leverage Google's backend infrastructure to build this container for me, and then it will automatically upload that resulting container asset to the container registry. So I'm going to use this command instead to do that.
Shout out to Container Builder. It's awesome.
Yeah, it's a cool tool, and it's continually evolving with more and more features. One thing not shown here are the triggers that you can put in place. So if you're using the source repositories, which are private Git repos within Google Cloud Platform, you can build a trigger where anytime you push to a particular branch, you can set the branch that you want it to trigger off of. It can then initiate this gcloud container build command I just submitted to kick off that build process. So it just finished building my Nginx container. And if I go back to container registry and do a refresh, I will now have a Snappass Nginx container directory. So we have that, and we have one container in there with the latest tag applied to it. So let me go back to this, and now let's build the actual application container that's going to hold the Snappass application. So let me copy this guy. And we're going to go back to the Snappass directory. So this is just get pulled, or get cloned rather, from the Pinterest Snappass repository you saw linked earlier. And there's a Docker file in here. So we're going to build this, and we're going to give it the name similar to the previous thing, the name us.gcr.io/Snappass, that number, which is my project, and then the name Snappass. And that's how Docker and gcloud knows to push it to Google's container registry, because us.gcr.io is a domain endpoint.
And real quick, how do you get all these commands? Is just part of the gcloud SDK that you download?
Correct. Yeah. So you can do all this from your local workstation. You can download the gcloud SDK on OS 10, Windows, and Linux. In this particular case, I'm running this from the gcloud shell.
Yep.
From a Chromebook. So this makes it really easy to open up Chrome, log into the GCP console, which is just the web UI, and then click a button in the upper right-hand corner of the GCP console to pull up the gcloud shell, which is what you're seeing me use here.
Yeah, I don't think that gets enough attention. The Cloud Shell. I mean, all my customers say like, "Oh my gosh, this is so cool!" Like, you don't need to open up your own terminal. You just click on a web browser button, and here we go, pops up a terminal for you to access all the GCP technology you need just from a single command line.
Yeah, for sure. It's a good security story too,
Mm-hmm.
as well. So, and it has all the wirings in place, so you don't have to do any sort of authentications or things like that. It's just ready to go. And it has gcloud, it's got Docker, it has Gradle, Maven, Python. It has a whole bunch of different build tools already there ready for you to use.
Yep, that's awesome.
All right, so the Snappass container has been built. Let's make sure it's there. And I need to go back one directory to look at that. And we have that. So we have our two containers. Now, I also mentioned Redis earlier. I'm not going to build that container. I'm just going to pull directly from Docker Hub from the official Redis repository, just to keep things simple. You could, of course, build your own Redis container if you needed to, which is, of course, a good security practice if you are doing this for your organization for production reasons or something like that. I'm going to skip this command because I already created the cluster earlier. But what I do need to run, I need to grab the credentials for this cluster. So it's a brand new cluster. I'm going to go back to my other directory real quick just for future work. And then since cluster 1, the GKE cluster already exists, I want to grab the credentials. So gcloud will pull those, create all the necessary kube config files that I need to talk to the cluster. And then now I can talk to the cluster via kubectl, just as you would if you had Kubernetes running on your own, or if you're using something like Minikube, which is a piece of software to get a local Kubernetes instance up and running for dev and test reasons. So we have 3 nodes in our clusters. Those are the names of the actual virtual machines. And if I went over to Google Compute Engine, you would see these 3 VMs there as well with the same names.
Very nice.
All right, so I have access to the cluster. The cluster's up and running. Let's actually deploy some stuff. Okay. So I'm going to start with Redis. And as I said, I'm just going to pull from the Docker Hub Redis repository. So kubectl run, I want to give this a name. I'm going to call it Snappass Redis. Image is just Redis. The reason it's just Redis and there's nothing before that is everything, any kind of tool that works with containers typically by default will point to Docker Hub. And of course, Redis, the company has, I think it's like the hub.docker.com/Redis. They have that specific to them. So that's how you know where it's going to point. I want to expose port 6379 internally. I want 1 replica. And then labels are just key value pairs, arbitrary key value pairs that you can set on anything. And you can use those for filtering later. So in this case, I'm just going to give it a name, Snappass-Redis. What tier is this? It's a backend tier. And what app is this? Snappass. And you'll see why that can be important later. Let me go through some of the other stuff. So that's going to pull down that container and then deploy it on one of the nodes in our environment. And while that's happening, I'm going to grab the second piece. So let me just show you real quick, get pods. So that created a pod called Snappass-Redis- that unique key. And it's creating the container right now. So it's in the process of downloading it and then creating that pod around it and getting it up and running. So it should take a few seconds and now it's up and running. So at this point, we have 1 pod with Redis inside of it, but we can't really do anything with it. So I'm going to create essentially an internal load balancer, and it's a Kubernetes service called cluster IP. And what that does is, and that service is called Snappass-Redis. What that does is allow any app within the Kubernetes cluster to talk to this particular instance of Redis using the short name Snappass-Redis. So I can do kubectl get services. And this is the internal service for Kubernetes. We don't mess with that. This is the one I just created. And this is the internal cluster IP that we will communicate with it on. And we can simply use Snappass-Redis to do that because there is internal DNS to the Kubernetes cluster, and it points that short name back to that cluster IP. So it makes it really easy to always ensure that you're talking to that Redis instance. And another important piece about the service is that if one of the node, or if the node the Redis pod, the single Redis pod is running on right now fails, Kubernetes is going to reschedule that Redis instance to a new healthy virtual machine. Now, the IP could change when that happens, but because that short name is always pointing to that particular service, Kubernetes is going to update that IP for you if it does change. So you're always going to be able to get to it no matter where that pod is scheduled in the cluster.
Yeah. So real quick, I noticed cluster IPs are internal. These are not publicly available or publicly accessible.
Correct.
Cluster apps.
That's correct. Pods. Right. Yeah. Right now, none of this is publicly accessible. We'll get to the publicly accessible piece later in a second here.
And then when you define replicas equals 1, that kind of enforces the fact that there's always 1 running.
Correct. So Kubernetes is a declarative system. You tell it what you want and it does it. It enforces that. So I mentioned earlier about the issues with state and Redis. If I were to do 2 replicas, we would be back in the situation where if the front end piece and the Python piece are trying to talk back to Redis, you have to have them clustered because they're not sharing information. So they'd be completely independent from each other. So
Right.
that's why it's just 1 replica. But the other pieces, the Snappass piece and the Nginx piece for the front end, are stateless, so we can replicate those as much as possible, and we'll be doing that here later. So let's go ahead and spin up the next pod. So this is a Snappass pod running the Python app. I'm pointing to my internal Snappass container stored in container registry. We'll do 1 replica right now, port 5000. That's the default port Python listens on. And I'm setting some environment variables. So I want to make sure that the Python app knows where to talk to Redis. So in this case, the Redis host is snappass-redis, that short name I specified earlier, and then a bunch of labels as well. So, and this is the piece that it'll take about 30 seconds to a minute for Kubernetes to pull this down to the cluster and then deploy it. And because it's a pretty large container, like the Docker file needs some optimizations on how that container is built. I think right now it might have some Python build tools and stuff inside of it, and that's definitely not best practice. You don't want to have stuff in the container that you're not going to be using within your app. You just want the app. That's one of the interesting things about writing applications in Golang is you can actually create what's called a sparse container, which is not backed by anything. It's not backed by like a Debian image or a Ubuntu image or something like that. It's just a sparse image, and then you just copy in that Golang binary, and it makes a very, very small container, assuming that Golang binary is small, and it's really easy just to like replicate that as much as you want, and it doesn't take up a whole lot of space.
Yeah. So it sounds like, I know we're waiting for that to spin up, but with that seems like a gotcha, right? With the stateful apps databases like Redis, you can't really scale out as easily as you would want with a stateless app. I mean, what are some best practices around that?
I mean, there's a lot of work being done to create. I think they used to be called pet sets. Now they're called stateful sets. But those sorts of resources within Kubernetes are being developed and worked on, and they're getting more mature day by day to be able to deploy those stateful apps and those databases in an appropriate way. There's also another Kubernetes resource called like a daemon set, where it's not necessarily specific for stateful applications, but if you need an app to run on every node in the Kubernetes cluster, you can create it as a daemon set, and Kubernetes will ensure that it's always running on every node in the Kubernetes cluster. So yeah, there's a lot of work being done and involved in discussion within the community to figure out what's the best way we can make like a generic thing to be able to deploy any sort of stateful application or database or something like that.
Right. And I don't think that you have to containerize it. Like, I think, sometimes you got the people who want to containerize everything,
Right.
but it's okay to have Kubernetes cluster talking to a stateful DB,
Oh, of course.
managed, or even this Redis could technically be in a VM, right? So,
right. Yeah.
Yeah.
Definitely. I mean, my motto is keep it simple. Don't get too crazy on what you're trying to do. At the end of the day, you want this stuff to work and work when you're not at work, so you don't get bothered when you're on the weekends or something like that. So, but yeah, there's definitely Kubernetes is arguably, and I'm somewhat quoting a video I watched of, I believe it was the Box co-founders, state that Kubernetes is the first true cloud platform because it doesn't matter if you're running it on GCP, AWS, Azure, or on-premise or anywhere else. It's the same thing you're talking to anywhere. And as Kubernetes Federation gets more mature, that is when things become very, very interesting, because instead of talking to one Kubernetes cluster with VMs and the pods on top of that, you're suddenly talking to multiple Kubernetes clusters, and you'll be scheduling things in the West Coast or Central or East instead of just on VM1, VM2, or VM3 or something.
Right. And that would be for like true high availability, right?
Yeah. You want to be as close to your customers as possible. You need that true, extremely high level availability throughout the country or whatever. Yeah, there's a lot of reasons for that. So Federation and Kubernetes is a very, very interesting thing that is, I think it's pretty mature in version 1.6, and it's just getting better and better and better. So,
yep.
All right. So the Snappass container deployed. There's a pod now created for that. I just exposed the internal load balancer service for that. So we can look at that real quick. And that also will get an internal IP address. So there's our Redis one. Here's our Snappass one on port 5000. It's been up for about a minute. So now let's deploy the Nginx one. And this is very, very quick because this container is not very big.
Hey, James, I have a quick question. So can Kubernetes reschedule the Redis instance? In that case, will all state be lost?
Yes. So all state will be lost if for some reason the VM that the pod is running on fails and it has to be rescheduled. In the case of this particular application, it's not a big deal. The person trying to send passwords to somebody would just have to go recreate that. So that's kind of a nuisance. But yeah, all state would be lost.
But Kubernetes wouldn't reschedule unless there was downtime or unless you've set some policy to move things around, right? I mean, they don't just reschedule for no reason.
Right. Yeah. I mean, so I mentioned earlier, this is definitely a getting started way of using Kubernetes. So the best practice way to kind of do what I'm doing is to put these commands into their own manifest files. And in those manifest files, which are typically just YAML markup, so it's fairly easy to read, you can specify things like this container should never need more than this much CPU and this much RAM on the particular host. And by putting those parameters in there, the scheduler is then able to make more intelligent decisions of where it needs to schedule those containers and all that kind of stuff. So it's important to do that. That's definitely a best practice to do in that. But yeah, back to the question, yeah, state would be lost in this case if it had to be rescheduled.
Yep.
All right. So that pod or that container is now up, and that's the Nginx front end. So now we have 3 pods. Once it kicks in here, that are up and running. We have Snappass the app, we have Nginx, and then we have Redis. So right now, I can't do anything with these services. They are not publicly available. They're only internally available. And I want to get to my app. The app is essentially deployed. I just can't get to it yet. So this is where, going back to that question earlier of why GKE over just doing this on your own, with that, there is that one-click deployment reason. With that one-click deployment, you get certain integrations with Google Compute Engine, or Google Cloud Platform rather. And the same applies to anyone else that is offering like a managed Kubernetes service. They're probably going to have integrations with their respective resources that you can spin up in their cloud platform. So in this case, I want to make that Nginx container public. I want that pod to be publicly available. So I'm going to create, again, a service, and it's going to be a load balancer service, but in this case, it's going to be an external load balancer service. So when I copy this in, this is actually creating a L4 cloud load balancer in GCP with a public IP address. So if I look at services again, now under external IP, this is pending. All the others don't have one because they don't need one. In this particular case, I want to create a load balancer so I can get to port 443, and that's going to map back to the port on the Snappass Nginx pod, and that will take about 30 seconds to create. And once it's created, if I went to the GCP console and pulled up the load balancer pane, you would see it an entry there.
So with that one command, you've pretty much launched the load balancer, connected it to the service or to the pod running in your Kubernetes cluster. And you didn't have to like create any VMs or anything like that. It just automatically does it because it's on GKE. Okay.
Correct. Yeah, I didn't have to go in and go to the load balancer section under networking and say, create a load balancer, create a backend service, create a front end. And like, there's a whole bunch of steps you typically have to do. This was all done in one command, and it finished provisioning. There's our IP address. So if I go back to a browser, and this is only accessible over port 443 for security reasons, this, of course, is going to throw a SSL error because we're accessing it via an IP address. And the SSL cert I have in place is looking for that snappass.pw domain that you saw earlier. So I'm just going to go past this. And here's the service that you saw earlier. So if I just type in something random here, make sure everything's working. Okay, so if I got to this screen, that means that the Python app was able to ingest that input, store it back into Redis, and give me this back. And let's make sure the full thing works. There's my very garbled password there. If I try to refresh the page, there's the 404 that I would expect. So I know things are working. So that's good. So we're up and running for all intents and purposes. So that quickly, we were able to spin up a cluster, deploy a bunch of containers to it, and get a working service up and running.
Nice. And I just went to the website too, so it works.
All right, there you go. Yeah, give it a shot. Anybody can access that right now and play around with it.
It's not fake. It's not fake, guys. I'm telling you, it actually works.
And just so this particular next piece, I just wanted to run through some of like the labels that you saw me create earlier. So you've seen me type kubectl get pods. Maybe I only want to see the front end pods. So this is where those arbitrary labels come into play. I can just pull up information for those particular pods based on the labels I set. And those labels could be anything you want. You could make a key value pair of Bob and Fred if you wanted to, or something like that.
Right.
Or a key value pair pertaining to what sysadmin manages these pods or something like that. So you could easily run a command to kind of see, oh, okay, he manages all these pods. And you go talk to them for troubleshooting or whatever. And it returns that. So I'm not going to run through each of these because it's pretty evident what these do. But the piece I do want to dive into is scaling. So let's say everybody on this live stream is suddenly hitting this service. Hopefully it doesn't crash for some reason.
Yeah, we have about 1 million viewers though.
Yeah, right.
Like that.
Hopefully we'll see. Hopefully when we scale out, I'll be able to do that. But from that diagram you saw earlier on the slides, the service, that Kubernetes service, as well as those pods were spread across 3 nodes. So let's do that because right now they're not spread across any nodes. They're only running on 1 right now. So let's go ahead and scale up the Nginx piece. And this again goes back to having the smallest container that you possibly can. This container has to be replicated to all the different VMs so it can deploy it. So the smaller it is, the quicker it's going to happen. So now, if I look at my pods, I now have 3 Nginx pods, and they're all going to be running on different nodes. And I can quickly see that by adding on this additional command line syntax or command line switch. And over on the right, you can see that the different VMs are represented by the suffix here with a different key at the end. So that tells me, okay, they're all on different nodes. Each of these pods have different IP addresses, but all 3 of those IP addresses sit behind that Kubernetes service I created earlier, which has a static IP address, and then it has that short name applied to it. In this case, Snappass-Nginx. And the same is going to apply for the Snappass pod here in a second. So let's scale that as well.
So this is good, right? I think it allows you to scale all your stateless apps, but it seems like from an application, you are still limited by the lowest common denominator, which could be Redis, right? In this case. Sure. So I guess, I don't know if you know the answer to this, but how do customers, or what would you recommend to, kind of design, these type of scaling, requirements? Do you just let Kubernetes kind of, do you put a policy in place that says, hey, if I have X amount of CPU, just keep spitting them up? Or do you manually go in and try to figure out how many you should be running?
You could do a mix of both. I mean, I think the panacea that everybody wants is that auto scaling. So you would leverage the CPU, the current CPU usage, the current RAM usage and stuff like that. And once you pass a particular threshold, Kubernetes can kick in and say, okay, I need to spin up more pods within my current cluster size. Now, if you get to the point where you exhaust all your current cluster resources, you of course need more VMs underneath, or if you're running it on premise, more bare metal servers underneath. So that's where you can leverage the auto scaling within GCP to also monitor the CPU utilization on the actual VMs, not necessarily a pod level or container level or something like that, and then spin up more virtual machines underneath, thus giving you more CPU resources and RAM to schedule for your pods and for the cluster to grow. And then once the utilization of your app falls, it can then auto scale back down. So you're not wasting money on unnecessary resources or something like that.
Yeah. Okay. That makes sense.
So I just kicked up or scaled up the Snappass piece, the Python web app. So now we have, it's kind of hard to read here, 3 pods for the Snappass container, and then the 3 pods below that for the Nginx piece. And then you can also get a good view of the deployments here. So there's the simple name that we created earlier, Snappass. I want 3 instances of that container. There's currently 3. 3 of those are up to date. 3 of those are available and in age, and the same applies to the others. So if I was to run this command when I scaled up the Snappass container, because it's larger, we would see some of those numbers go back and forth, especially if you ran that command with like a watch Unix command, so it updates like every second or something like that. You would see those numbers go up and down as it deploys things out.
Yeah. So it sounds like deployments are the actual types of containers, whereas the pods would be kind of the number of those deployments you have.
The deployment is Kubernetes resource similar to a service. A service is a Kubernetes resource. So a deployment is what manages the pods inside of it. So if you say, like when I scaled it up, I wanted to scale up the deployment, and then it takes care of replicating out those containers, or those pods rather, to additional nodes for me.
Right. And those pods could have multiple containers in them.
They can, yeah. A pod, in this particular case, a pod only has one container. There's actually an invisible container in there that you typically can't, or that you can't see, that is there for Kubernetes to do management and admin tasks. But yeah, if you have a situation where it makes sense for, maybe you have a stateless app that it needs container 1 and container 2 to operate, to do its function, and it makes sense to keep those as close together as possible, you could definitely put those in a single pod. There's nothing stopping you from doing that, because that will inherit, as you scale that, it'll still scale together. And you could also put it into separate tiers, separate pods if you wanted to. Perhaps that one function doesn't need to scale like some of the other stuff. So that would be a use case where you would separate it. Otherwise, just keep them in the same pod together.
Right. This is great.
Yeah. So, and then kind of the last piece here, we could scale these down, but one thing I wanted to show is I want to update one of these. So let me go down to the pushing upgrades here. So real quick, let me just make sure I'm telling the truth here. Let me go back to.
Yeah, you're known for lying a lot, right?
Oh boy, yeah. Let me look at the SSL certificate for this. So I'm going to go to security tab. I want to look at it. This should be out of date. Yeah, and it is. So this is a Let's Encrypt certificate that expired on April 20th. We're already getting an SSL error.
Oh, it is a Let's Encrypt. Okay. There was actually a question, and I probably responded inaccurately. They said, yeah, how does SSL work? Is it Let's Encrypt SSL?
So in this particular case, there's so many ways you can do this. The Nginx container that I have, it's SSL is all baked into that. I could offload SSL to a load balancer. I would have to use a different load balancer in this case. But in this particular use case, this Let's Encrypt certificate is managed by Nginx inside of that container. There are use cases where, and I believe Kelsey Hightower has a demo of this in his GitHub repository. I've seen him give it at a customer, and it's pretty cool, where he has a whole entire tier that's just Let's Encrypt, and it will manage all the certificates for everything underneath it and stuff like that. But it's definitely something that there's lots of pieces that connect together. But there's a lot you can do here, and there's probably a lot of different blog posts and people running through instructions on how to set stuff up like that to make things easier.
Right. That's part of the app itself, though. That's not like is it like a Kubernetes thing, or is it?
It'll leverage like Kubernetes resources like deployments and config maps and all that kind of stuff. But it is like its own container that's managing all this stuff as well, I believe.
Okay.
So I've never played with it, so I could be misspeaking a bit. But for the last bit here, I want to update this certificate. So what do we have to do? So if I go back to my shell prompt here, so in this directory, I have the SSL certs. So here's the old ones right now. These were copied into the Nginx container when I created it. So let's copy over the new ones. So I have in my home directory those new certificates available. So let's put those in, and it's going to overwrite these old ones. Make sure the date changed on those, or at least a different size. Let's see. Yeah, we should be good. Okay, so I don't know why that didn't change. That's interesting. Maybe they are the same. Okay, in any case, let's see if this works out. So I'm going to go back one directory because that's where my Docker file sits. I want to build a new container. And that's the same command we ran earlier. So now it's going to go through and copy back in all those things. And whenever you build a Docker container, there's multiple layers to it, and it quickly scrolled by there. But if a layer hasn't changed, it can just reuse that. So it's a quicker build, and you can see layer already exists. So that's where it's using existing layers, and they all stack on top of each other to build the final image. So now it's built the new image. It's pushed it up to the container registry. Let's go look at that real quick. Where do I have that up? Let's go to this guy. Go back over here. If I go into the Snappass Nginx container, I now have two containers. One with, or the newest one has the latest tag applied to it. And then if I wanted to tell Kubernetes to deploy or pull down a new container and deploy it across the board, I can use this command. And this time I'm specifying a new image with the latest tag here at the end. So that's essentially changing the image string inside the deployment kind of configuration to say, pull the latest down. And remember, there's 3 instances of that Nginx container running. So it has to go through and let's see if I can catch it in time. I may not be able to. Take down some of those. It's too verbose. But yeah, I think it did it too quickly in this particular case, but sometimes I can catch it to where it says available 2, available 3. And what it's actually doing is it's creating a new, I believe it's a replica set or a replica controller. One of those 2 is being deprecated. I can't remember which one, but it creates a new one, creates the new container, and then removes a container from the original one, and then rinse repeat that process until it's done, and then it destroys the old one and the new one is up and running. So assuming I copied over the proper certificate, and I have a feeling I didn't, we'll find out because they were the same size. Let me do a empty cache and hard reload. Let me see if it was updated. And of course, as I thought, it's not. I must have copied the wrong certificates. But of course, when I did this last night, it worked. But that certificate should have been updated to reference a date that has not yet transpired or expired.
Right.
So,
right. But we get the idea. So makes a lot of sense. So no, this is a really cool demo. I think obviously a lot of applications that we deal with customers are much larger and more complex, but I think the fundamentals around how you containerize it, deploy it, expose an IP to the public, things like that, I think we've covered here.
Yeah, definitely. So, and then it's really easy to clean all this up. I just run those 2 commands right here. And based on those labels I said earlier, it'll clean up the deployments and the service that I created. So it'll actually go in and delete not only the pods and the containers that I created, but that load balancers, that external load balancer service that I created. So I don't have to go and do that manually. So that's nice to do, or nice to have it do for me. And then I can run the last command to actually delete the cluster.
So. Very nice. So let's see here. Are you deleting them right now? Oh, you're not.
I can. So okay. I mean, that was pretty much the demo to show. I'm actually going to leave it up and running real quick to try and troubleshoot why those certificates were not what I thought they were going to be. So
yeah, no, that's fine. Things like that happen. So that's great. Thank you so much for doing that.
Yeah, of course.
If there's any questions on the chat, we'll stay on for a couple minutes.
Yeah.
Thanks a lot for joining us today. We did ask the question about the SSL certificate coming from Let's Encrypt, and I think you said that that's actually done inside of the code itself, right? Or is it something that Kubernetes provides?
So there's a lot of, so if the question is just getting the SSL certificates, there's a lot of ways to do that. My favorite is using a tool called Lego.
Okay.
And it's given that name because it's Let's Encrypt in Go.
Got it.
It's a Golang application that interfaces with the Let's Encrypt APIs to very, very quickly pull down and create SSL certificates. I actually have a post on my blog. If you just do a search for Lego, once you actually land on the blog page, that goes through the process. It's the process I use to get new SSL certs. It's a bit manual, but it's a quick way just to get certs and move on.
Yep.
And then once you do that, you can go down the path of figuring out how can we automate all this, because there are ways to have like a Let's Encrypt agent run to continue, like every, I don't know, day or something, it'll go and check the Let's Encrypt API to see if it needs to get a new certificate or something like that. Or as it gets closer to expiration, it'll go ping the API and say, hey, I need to renew myself. It'll pull down the new cert, put it in place, restart Nginx or Apache or whatever web server you're using that it is compatible with, so you can automate that entire process.
Right. Yeah, no, it's the security stuff that's kind of way beyond me, but obviously automating that process is really important.
Yeah, for sure. I've been bitten by expired certificates before, especially with Let's Encrypt having a requirement of the certificates only being valid for 3 months. It's important to have that automation in place.
Yeah.
And I think they do that for security reasons. So if for some reason the private key for a certificate leaks out or something, it's going to be revoked pretty quickly, or the cert itself is going to be renewed pretty quickly or something like that. So,
and maybe my last question while we're waiting for questions from the chat is, what are your thoughts about kind of Kubernetes going forward? How do you see it? Do you see it as becoming kind of like an industry standard, sort of like how containers are slowly becoming, the standard for application deployment. Like today, if you were going to build an application, like why would you not use Kubernetes? It's almost like every customer I see, it's kind of the default. Like, okay, we're going to start with Kubernetes. Does it make sense not to use Kubernetes? What are your thoughts around that?
Yeah, I'm of course biased, and I became, not just because I work for Google, but once I started playing with Kubernetes, having been a Linux sysadmin for a long time, Kubernetes was finally made ops interesting again. It made it fun.
Yeah.
And just using it and seeing how easy it was to containerizing stuff is one thing, but once you have that done and you have your asset, your container, just seeing how easy it was to get a GKE cluster up and running, put those containers into container registry, get them pulled down just with the commands you saw today, I was sold. And this is just scratching the surface, what I've shown today. There's so much more here to dive into, and there's so many more things coming out from the community. Kubernetes, I think, is the way forward, and is from my personal point of view, this is not representing Google by any means. I think it's the container orchestration platform to deploy on.
Yeah, I mean, I was in ops a while back as well, and what's interesting is kind of the role of ops is kind of moving up the stack, right? I mean, before it was, installing the OS, adding all the runtimes, the libraries. I mean, that was not fun at all. I don't think anyone can say, oh man, that was the most exciting time of my life. I think what's exciting now is being able to see these applications deploy quickly and being able to take care of kind of the more important things, as opposed to, oh, what version am I running on? Oh, I need to update this to the latest version. Oh, what security patch is it? I mean, those were not fun times, but now it's like, the role of operations has moved up towards, like, and that's why they call it DevOps, right? Being able to automate a lot of the deployment process of the application.
Yeah, it's definitely a cultural shift. I mean, DevOps it's a role and a culture that has to be followed to execute it properly. But what's interesting about what you just said is a lot of that now moves up into the container itself. So, I mean, you can have packages running in a container that have exploits in them. So you got to make sure there are tools out there. I know Docker has something. I think Qualays also has something where as you deploy your containers to their container registries, they have tools that'll go in and scan the container to see what versions of packages are you running. Do they have any exploits? Notify you of those exploits, so okay, I need to update this container so I can push a new one out across the board. And when you do that, I mean, you have something like Kubernetes there to quickly push that out to everybody or every node. So it doesn't matter if you have one instance of that container running or 2,000. It'll take care of that rolling update for you and provide rollback functionality as well if something goes wrong that wasn't caught in like your deployment pipeline or something like that.
Yeah. So, we did have a question. Alan asked, was not able to be at or follow Google I/O. What else is new in Kubernetes or GCP? Ooh, that's a loaded question. There's so many things.
It's like a whole other discussion.
Yeah. I mean, Google I/O, obviously as Google Cloud Platform is slowly, becoming, I mean, we're investing heavily in that. So, Google I/O was traditionally not Google Cloud specific, but now, they've been talking a lot about machine learning.
Yep.
But I don't think, I mean, Kubernetes itself, a lot of the action is really I mean, there's a conference for Kubernetes. But
KubeCon, I believe, will be in Austin later this year. And Google Next is where most of the Google Cloud Platform announcements happen. And a lot specific to the question around like what's coming in Kubernetes, or at least in GKE, we mentioned earlier the kind of hybrid managed or half man, whatever you want to call it, how it's not yet kind of a fully managed service, and we're getting more and more to that point. Those are the features we're working on to get to that point, such as automatic upgrades of the Kubernetes software stack in the cluster. Instead of having to click a button for you to do it yourself, we'll do it for you, pushing out new features in an automated fashion and stuff like that. So there's a lot of work being done there to truly get to that fully managed service point.
Yeah, exactly. Shraddha had a question. How do you update container with zero interruption or downtime? I think you talked a little bit about kind of the rolling updates. You want to just quickly mention that again?
Yeah. The deployments allow you to do those rolling updates. So what it's doing, like if you imagine you had like two knobs in front of you, let's say the knobs are go to 1 to 5, both knobs do that. Knob number 1 would be the original kind of deployment running, knob number 2, it wouldn't be a new deployment, but just for the sake of this conversation, pretend it is. Knob number 2 moves up from 0 to 1, while knob number 1 moves from 5 to 4. So you're always going to have like 5 instances of the container running, but at that point, you now have 4 instances of the old container running, and then 1 instance of the new one. And then that process continues until you're fully up to date. And what wasn't shown today is in those manifest files. So instead of doing all this from the command line, in the manifest files, you can add in, what are they called? I think they're called like health Z probes or live Z or something like that, where it's actually an endpoint listening in your container. So Kubernetes can hit that endpoint. It's just an HTTP endpoint that it can hit, and it knows that if this returns a 200, this container is ready to begin serving traffic. So
got it.
You can have that in there, and once it sees that, it says, okay, this one's live, then it'll flip it up. If it doesn't get a 200 back, it's not going to bring that container up, and it'll throw an error, and it'll probably stop that deployment. It'll stop that rolling update. So it kind of gets you down the realm of those blue-green deployments. I believe Netflix calls them red-black deployments because those are their colors, and things like that. So yeah, dive into Kubernetes deployments and how it works underneath that.
As it's oh, go ahead.
No, go ahead.
I was going to say, as it's doing the rolling update, is it just splitting traffic, or is it round robining between kind of the old and the new version until all the old versions are gone?
I don't think it's splitting traffic. There may be a way to configure that if it doesn't already do that, but it's not going to send traffic to something that's not yet ready. It's only going to send traffic to containers that are up and running. So interestingly enough, so Kelsey Hightower was just at Chef Con. He just did a presentation, a really cool presentation of, he wired up Google Assistant to GCP using the chatbot services from API.ai, where he had an existing GKE cluster up and running. And by talking to his Google Pixel, he said, okay, Google, talk to Kubernetes cluster or whatever. That puts you in the context of this app that he had. I forget what it was called, but let's just say it was called Kubernetes cluster. He could then say, deploy Hello World version 1. And it knew to go pull some Hello World app, deploy it out. And then he went on to show a rolling update. And while the update is happening, he just has a curl command recursively running to show the version. And then you can quickly see it goes from like version 1 to version 2 with no drops in.
Wow.
Granted, that's just a Hello World app. And things can get more complicated if you have a service with heavier traffic or more complicated logic and stuff like that. But definitely check that out. It should be findable from a Google search. Chef Con, Kelsey Hightower, Google Assistant demo, Kubernetes or something like that. You should be able to find it. But yeah, the mechanisms are there to enable those rolling updates with as little downtime as possible.
Right.
Hopefully none. So
cool. That's great. I think that was the end of questions, and we're 2 minutes before the top of the hour. So
all right,
thank you, James. That was great.
Welcome.
Yeah.
Thanks, Jonathan. Appreciate it.
Yep. Thank you, everyone, for joining, and have a great weekend.
Great. Thanks, everybody. Bye.